Hey there. If you've ever just sat there staring at a Python class, wondering if a method should be an instance, class, or static method, you are definitely not alone. It's a super common sticking point. But today, we're going to make it all click. We're going to demystify this whole thing for good.
Getting this right isn't just about avoiding a syntax error. It's really what separates clean, professional code from code that's, well, kind of messy and hard to maintain. But don't you worry, we're about to clear all that up.
So what's the secret? It's one simple analogy. That's it. I want you to think of your code like a school. This single idea, with its students, the school itself, and a few other helpful tools, is the key that's going to unlock everything for us.
Okay, first up, let's zoom all the way in on the most fundamental part of any school, the individual student. This is where we find our most common type of method, the good old instance method. So what exactly is an instance method? Well, think of it as a function that belongs to one specific object, or instance, of a class. The absolute key here is that it works with data that is totally unique to that one object. And its magic wand is that little word, self. Let's look at a bit of code. Here we have a simple student class. You can see we're creating two totally separate students from it. S1 is our student Allie, and S2 is Sarah. They're built from the same blueprint, sure, but they are two unique individual people. And this just maps perfectly to our school idea, right? Each student is a unique object. So when we call the showName method on S1, it looks at its own unique data and gives us Ali. If we do the exact same thing for S2, we get Sarah. The method knows exactly which instance it's working with. And that's why self is so important. Just think of it as a little pointer. When you call s1.show_name, Python uses self to point right at the Allie object and say, hey, I need this specific student's name. Without self, it would have no idea whose data to grab. All right, so we've got the individual student covered. Now, let's zoom out a bit. Let's look at something they all share, the school itself. And this brings us to our next type, class methods. Now, a class method, unlike an instance method, could not care less about any one student's unique info. Instead, it works with data that belongs to the entire class, the whole school. And you can spot them a mile away. They've always got that @class method decorator on top, and they use class as their first argument, not self. Take a look at the code here. See how we've added a school name variable right inside the student class, but it's outside of any specific method. That means it's not unique to Ollie or Sarah. It's a shared attribute of the entire class. It's a fact about the school that applies to everybody. And you can see that right here. Doesn't matter if we ask student 1, Ollie, or student 2, Sarah, hey, what's your school's name? They both give the exact same answer, ABC School. They're both tapping into that single shared piece of class data. Now, this is where class methods get really cool and powerful. If we use a class method to change the school's name, let's say from ABC to XYZ School, that one change is instantly reflected for every single student object. Change it once, it updates everywhere. So, when would you actually use these? Well, managing shared data, like our school name, is the #1 reason. But they're also fantastic for creating what are called factory methods. Think of those as alternative ways to create an object, like maybe building a student's profile from a single line in a spreadsheet file, instead of just a name. So we've done the student and we've done the school. But what about things that are just useful to have around the school, but they don't really belong to a specific student or the school itself? Well, that brings us to our final type, static methods. A static method is pretty much a regular function that we've decided to park inside a class, usually just to keep things organized. The dead giveaway? It doesn't take self or CLS. It's a lone wolf. It can't touch any instance or class data. It's just a self-contained little utility. I mean, look at this example. A simple add function inside a math class. To do its job, does it need to know a student's name? Nope. Does it need the school's name? Not at all. It's a totally independent helper. It just takes two numbers and gives you back the sum. So you're probably thinking, okay, if it doesn't need the class, why on earth did we put it inside one? And the answer is just one word, organization. It's about keeping related tools together. It just makes sense to group a bunch of math helpers in a math class. Okay, we've defined all three. We understand the student, the school, and the utility. Now for the most important part, the payoff. How do you choose the right one for the job? This table right here,
This is your new best friend. It's the ultimate cheat sheet. If you need data specific to one object, you need an instance method with self. That's our student. If you need data that's shared across the whole class, you need a class method with CLS. That's the school. And if you need neither of those, you just need a helper utility, and that's a static method. And this all boils down to a super simple 3-question rule. When you're writing a method, just ask yourself this. Number 1, does this method need data that's unique to an object? If the answer is yes, boom, it's an instance method. You're done. If it's no, move to question 2. Does it need shared class-level data? If yes, it's a class method. And if the answer to both is no, congratulations, you've got yourself a static method. Simple as that. Okay, let's take this out of the classroom for a second. Let's see how our whole student-school utility model translates into a real-world coding scenario that you might actually encounter. So let's trade our school for a video game. A single player's unique action, like their move command. That needs that player's specific location and stats, so that's an instance method. What about a counter for the total players currently online? That's shared by the entire game, right? Classic class method. And a generic function to calculate damage based on a weapon and armor type that doesn't care about a specific player? That is a perfect utility for a static method. And that's really why all of this matters. Getting this right isn't just some academic exercise to make the computer happy. It's about communicating what your code is trying to do. It makes it cleaner, more logical for other people to read, and yeah, it makes it look and feel a whole lot more professional. So there you have it. You now have the key, the school analogy, and that simple 3-question rule. The only question left is for you to answer. Thinking about your own projects, what's the first piece of code you're going to go back and organize with this new clarity?